Hi everyone, welcome to the workshop and my presentation entitled Modeling an Industrial Revolution, How to Manage a Large-Scale IoT Ecosystem. I'm very honored to be here again um, at the Management for Industry 4.0, a great workshop series for discussing matters around the new industrial revolution and also in particular around the Arrowhead Tools project and Eclipse Arrowhead, its underlying technology. So my name is Geza Kulcsár. I'm from Inquiry Labs, a Hungarian SME, and this work will kind of present a very broad perspective on what we've been up to in the Aerial Tools project in the past year or so, um, and therefore my collaborators on this are also numerous, all representing or expertising in different facets of Arrowhead Tools. Uh, These are Pál Varga from the Budapest University of Technology, Marek Tatara from the Dansk University of Technology, Federico Montori from Bologna, Michel Inigo from Mondragon, Gianvittore Gese from Turin, and Paolo Azzoni from the Eurotech company. So let's go. Um, I'm pretty sure you will not remember, but in any case, I will let you know that this motivation slide is the exact same as I've used in my first Management for Industry 4.0 presentation. Why is that? Because I wanted to emphasize that this very question still lies under each and every problem statement which we might want to look after in this industrial modeling context. So the essence is still, are we able to come up with means of modeling, means of capturing the structure of the various aspects of Industry 4.0 with having a clear understanding of a given structure and also retaining it throughout the process, while also being able to providing a flexible dynamic behavior description of the system. Essentially, so I've listed all these fancy and trendy keywords such as IoT or industrial IoT, system of systems, cyber physical system, digital twins, etc., etc. While these keywords are not coming at us, but what they have in common is this actual wish to capture some structure, but also providing that level of autonomousness, adaptiveness, and dynamicity which is expected in the new era of industry. And an observation of many researchers, and also in particular of those involved with the Arrowhead platform, that the key factor, or at least one of the key factors in achieving this, is to lay a very particular, very acute focus on interoperability. In order to be able to pursue that even more effectively, what Arrowhead relies on are the principles of the service-oriented architecture, which allows you to provide to a certain extent fixed and rigorous system and service description um, library, while also allowing your systems to decide on certain communication channels and connections in runtime or as late in the process as possible, as often expressed by the concept late binding. But what is the role of modeling in this whole story? So modeling here in this context, we do not just mean the usual take on systems modeling, which would be the de facto systems design when I'm actually executing or planning the component architecture of an actual physical system. Um, Essentially, to model is to find an appropriate abstraction or a number of appropriate abstractions over a certain domain, here Industry 4.0, organize them into a structure, and establish conceptual connections between those layers. in order to foster interoperability and to break the silos which would otherwise keep the information of different layers in themselves and not letting them to interact with the other facets of the complex domain at hand, because Industry 4.0 is obviously a complex domain. So how do we model an industrial revolution then? Arguably, RAMI 4.0 kind of does the job as a central reference model, and it fulfills our expectations towards such a model as we have defined the meaning of a model on the previous slide. However, it rather represents a high-level management aspect, and while of course it aims to be omnicomprehensive, it more or less lacks actual guidance for architectural aspects. Therefore, what I would want to really have more attention for in this talk are exactly those aspects and how these are reflected and represented in the overall Arrowhead ecosystem. Especially what I would want to uh, give you a quick walkthrough through are the engineering process modeling, which is again a very general uh, viewpoint, the engineering process modeling aspect of Arrowhead tools, um, the how you can actually design system of system architectures using the good old SysML, the system modeling language, and also um, it, after introducing a very important concept um, for Arrowhead tools as well, but also for I think the whole future of Industry 4.0, the concept of toolchains will also go through the concepts of around toolchain modeling as well. So, but let's go. We start with the Arrowhead engineering process itself. So this is just um, so this has been elaborated in other papers. Here I will give you a quick walkthrough, and then I actually just want to pinpoint one particular aspect or property of this engineering process. Um, these are pretty typical. Actually, the first five blocks or phases of the engineering process comes from an established standard, which is not listed here, but it's called the I think it's called the extended manufacturing model. And then there are three other blocks, which makes it a bit more, even a bit more open-ended, which has been added at the uh, as the Arrowhead engineering process started to be developed. Um, this is what a concrete engineering process or concrete configuration would look like. And what I would actually really want to highlight here is that we are looking, as we have seen, modeling is not just finding the abstractions, it is also about finding the glue between them, those points where different aspects can touch. This is the first slide where I show you that actually between an actual Arrowhead process configuration, so an instantiation of the engineering process for some purpose, for building a use case, obviously involves the specification of sub-interfaces of how you would communicate, let's say, for example, um, the data flow between your requirements management and your actual functional design, or your functional design and your training materials, or even educational software, whatever. Of course, there's a number of other interfaces. So let's keep that in mind. That I will keep going ahead. What is SysML? SysML is a widespread, or the most widespread actually, industrially established systems modeling language. It is also a standard maintained by the OMG. It is built upon UML, and it is actually the de facto baseline for any systems engineering activities nowadays. Uh, the The version used everywhere is still SysML version 1, now in its version 1.7, but a new major release, SysML version 2, is also around the corner and will come out later this year. We will not spend too much time today, unfortunately we cannot, on the details of how we can model Arrowhead system of systems, so actual Arrowhead use case setups, their architecture in terms of systems, services, and devices using SysML. We have created a SysML profile for that. Actually, it has turned out to be very, very useful. This is just a random excerpt of an actual use case provided by Bosch within the project. And this is just to give you an idea of how such a setup could look like. This is just an excerpt. It can be much bigger, but I hope this quick glimpse on that gives you a feeling of how useful such a design artifact can actually be. On top of that, so this picture came from a tool which is called Cameo Systems Modeler, which is very widely used in the field. Also, more recently, the developers have thankfully also added support for this Arrowhead SysML approach in Eclipse Papyrus, which is another tool. Then there are a number of features on top of that, kind of as a modeling toolkit built upon this Arrowhead profile which we have created. So there's an export import feature communicating with the Arrowhead management tool. You can validate your models. You can even import device digital twins from a nice kind of catalog environment, device catalog environment called Eclipse Photo. In Papyrus, there's an additional cool feature available where you can directly generate client code from certain models using the fabulous Open API generator, etc., etc. I promise that I'll also get to the tool chains. So this is the textbook definition, what we came up with for Arrowhead. So this is in quotes because this is part of an actual delivery of Arrowhead where we wanted to fix the meaning of each and every important concept within Arrowhead, and this is a tool chain. Obviously, it's a collection of tools, but we interpret the tool chain concept very widely. It doesn't have to be really connected with the Arrowhead framework technology. It's just that you create an innovative setup of tools, an innovative collection of tools, and their flexible chaining in order to bring some real benefit for your Arrowhead use case, for the engineering of your Arrowhead use case. So this is why I've taken the courage to bring you a very special example of how such a toolchain can look like. This is the called the Arrowhead Design Suite, which is special because it has been partly built using this SysML technology which I've been talking about and those tools which belong to it, but it is a tool chain in itself. So these are some elements, like there's a tool for designing tool chains actually, which will be interesting pretty soon. Then you can design your system of systems. Basically, the diagram which I've shown before came from this tool. Then you can also have some means for reasoning about deployment to devices. This is the Eclipse Photo part. Then there's also a process modeling plugin, which I will not go into today. And this all communicates with a part of the Arrowhead framework, actually the main management interface of it, called the Arrowhead management tool. So to have it a bit more detailed, this is the actual concept for interoperability. So you have your SysML models there, you have the management tool on the other side, you want to have some communication in between. This is called AHX, Arrowhead Exchange. I'll explain it in a moment. and with that you can have a bridge between different engineering process phases, here in particular between functional design and operational management, and also others. So what if I want to bring this concept into an actual toolchain model? Now I have the means for that. I just have to take my customized SysML with this nice colors and visualization and everything, which we have developed for Cameo Systems Modeler. Then you draw two tools. For example, of course, this is just a part of the Arrowhead design suite, but the full thing would have been too big to present in this presentation. Therefore, I was just focusing on this part. Um, so you're creating a tool box for your Magic Draw, which is the same thing as Cameo Systems Modeler. You're creating another tool box for the Arrowhead management tool. Then you can express via arrows that it's a bidirectional communication. Of course, you can state which phases you're actually covering. It's not only functional design, but also more. But it's not the main thing here. What I would really want to highlight is this data structure box here, which is called AHX. So this is the actual data format used for exchange, which I've already talked about. So Arrowhead Exchange is something which we created for this exact purpose, for this exact tool chain. It contains exactly those system and service details from an Arrowhead SoS design, which is needed for the runtime systems managed by the Arrowhead management tool to work. So in particular, this is how this can be modeled in SysML. And this is why I said in the beginning that thinking in terms of interfaces in whatever layer of this complex Arrowhead management ecosystem, thinking in terms of interfaces can be useful, because if you have a language where you can express your data structures, in this case this is SysML, then you will be able to reuse those artifacts in defining your toolchains. So while you're performing toolchain modeling, you might be able to reuse these kind of artifacts in actual SysML-based SOS architecture designs, and you could also use the same interface specifications for specifying your engineering process around this whole use case which you're actually working with. So just to get back as a conclusion to where we started, in this new era of industrial IoT networks, their management is obviously poses a number of new challenges. In this talk, we had the intention to talk about some of the architectural aspects which have been not really deeply covered in previous work. However, I want to mention here at this point that obviously um, RAMI 4.0 is still a central reference of the field, and aligning its concepts with those of Arrowhead tools is absolutely feasible, and it is an important goal. I didn't have the time to go into details in this talk, but feel free to read our paper for more details, and of course get back to us if that part has catch your attention. As for future work, it is, and as it is always the case for such modeling endeavors, uh, the concepts have been, so the basic concepts have been worked out now, and there are some prototypes around to play around with them, but there's still a great room for generalization into various directions. And as a to close my presentation, I would want to show you an example which we are actually working upon. So since the paper has been written, there has been some great advancements which actually belong to the then future, now present work which we are performing in this direction. So in order to achieve real toolchain level interoperability, which is kind of the key here, we kind of started working on the next generation of the Arrow design suite, which is now called Semantics, a new level of interoperability. I know this sounds um, uh, very much flashy, but uh, this is what we think it will become. Um, so here we want to deal with even more formats and more a more flexible ways of data interoperability than it was thinkable before. So this concurrent presence of different data representations and different data formats and different data standards is something which is inevitable for Industry 4.0 and which we should embrace, but it of course can also be an impediment to interoperability. The semantics, where the easy interpretation of the word is just these data structures which you have seen, so the actual meaning behind the representation is of course a key issue. The new distribution of the Arrowhead design suite which we are working upon, which is now called Semantics, will be a fully web-based uh, flexible interface providing data integration coming from different sources, not necessarily only SysML models, but also other like semantic web data, ontologies, runtime data, whatever, transforming them into each other, and with that also like breaking this necessity to always formulate your interfaces in one given format. And also this will give you some further uh, analysis technologies or rooted in modern model-based systems engineering. If you want to take a sneak peek on that, I advise you to watch this very short but I hope informative video which we have just recently uploaded to our YouTube channel. And with that, I'll stop here and I thank you for your attention.